Hi guys, this is my first attempt at a screen recording so that we can look at some of the things that we cover in class. So here we go. This is the picture I have, taking the derivative by definition. Limit as h goes to 0 of the function evaluated at the point plus h minus f of that value divided by h. And pictorially, here's what you have. As I let h quite literally approach 0, because h is the distance from here to here, as I let h approach 0, we can see the blue secant line approaching the tangent line. But this isn't anything that's unfamiliar. We already knew this. So I have the red tangent line drawn in, and again, I'm letting h approach 0, and that's what we do when we calculate this limit given some function, which I'll show you in a few minutes. Now look back over to this one. This limit looks slightly different from this limit, but the picture is identical, so let's look at the same thing. Now here, I let h approach 0, because this distance was h. But here, this is an h. This distance is actually x minus x sub o, which I have drawn here. So I don't want to let I want to let this approach 0. In other words, I want to let x minus x sub o approach 0. So basically that's the same thing as saying let x approach x sub o. That's exactly the same thing. So when I do this, as you can see, this distance is still x minus x sub o. Now f of x is going to get closer to f of x sub o, and the blue secant line approaches the red tangent line, just like it did over here. So now your job is to stare at these pictures for a little while and make sure you understand the difference between the two limits. And now my job is to look at this. So now what we're going to do is we're going to evaluate the derivative, f prime at 3, of this function, and we're going to do it the old way, the way I taught you in the first place, and then we're going to do it with this slightly new notation. Okay, so here we go. I'm not used to using this pen thing, so bear with me, okay? So the next step I'm going to have limit as h approaches 0. Now f of 3 plus h would be 3 plus h squared plus 2 times 3 plus h minus f of 3. Well, f of 3 is fairly easy to calculate. It's going to be 9 plus 6, and I'm pretty sure that 9 plus 6 is equal to 15, all of which is over h. So now I have the limit as h goes to 0 of 9 plus 6h plus h squared plus 6 plus 2h minus 15 all over h. And this is the limit as h goes to 0. Now I have 9 plus 6, which is 15, minus 15. So those three add to 0. And now what I have left, everybody has an h in it. So technically 6h and h and 2h is 8h. So if I factor out an h, I'm going to have h times 8 plus h. And this h is left over from this h squared when I factor that h out. And the whole thing is over h. So these h's cancel out. My surrogate function is 8 plus h. And now I have, if I take that limit, I will simply get 8. Okay? Now let's look at the new way to do this. We're going to do now, this is going to be f of x, which is nothing more than what it says. Literally, we're going to take the limit as x approaches 3 of x squared plus 2x minus, now f of 3 we've already determined that's going to be 15, all of which is over x minus 3. So then the limit as x approaches 3, now x squared plus 2x minus 15 can be factored into x plus 5 and x minus 3, and that whole thing is over x minus 3. So you can still see the limit as x approaches 3, we're going to get a 0 over a 0 here, which is like indeterminate, so we've got to do something. In this case, that something is find a surrogate function, so these cancel, and my surrogate function is now the limit as x approaches 3 of x plus 5, which is clearly equal to 8. Okay, so these are two different ways to evaluate the same derivative. You really should know both. I mean, generally speaking, we're going to use this one the most, but this one does come up on occasion, as it did like when I was proving the chain rule the other day. Okay, so I'm going to cut this video off because I think it's getting kind of long. Good luck. I'll see you on the next one.